Hello, my little mathematicians. Today, we're going to work on solving and writing proportions, and then we're also going to explore proportions that involve scale drawings, as well as how to solve proportions by using what's called the unit rate. Okay, so if you could please find your foldable that looks like this on one side and this on the other. Okay, so it looks like this. Let's go ahead and start at that top section. At the beginning, the first thing, let's just start off simple. And let's review solving a proportion. Now, this word proportion is basically two separate ratios set equal to each other. Remember, a ratio is another word for a fraction. So when you have two ratios set equal to each other, that's what forms what's called a proportion. Okay, so I'm going to solve this proportion just like how I did in the past. So I'm going to look to see, always move in the direction towards your unknown. So I want to go from the 4 to the unknown, which means I'm going to go to the 7 to the 42. So what do I do to this 7 to get to 42? Well, I would multiply by 6. And whatever you do to one term, you have to do to the other term as well. So 4 times 6 is 24. That means that this ratio of 24 over 42 is equal to this ratio of 4 over 7. Okay? And when you have two ratios set equal to each other, that's called a proportion. So let's go ahead and try to solve this proportion. Okay, again, go towards your unknown. So I'm going to go this direction. 3 times what is 27? 9. So then 2 times 9 is 18, which means this missing blank would have to be 18 to make this ratio be equal or equivalent to this ratio, or have these two this proportion be equal to each other. It's simple if they give it written to you and you're just finding the missing piece, but what if you have to set up the ratio yourself? Okay. Well, this problem says Martha wants to enlarge a photo that is 3 inches wide by 5 inches tall. The enlarged photo keeps the same ratio. How wide is the enlarged photo if it's 10 inches tall? So you know you want to set up a proportion if they give you 3 pieces of information. The 2 pieces of information that are usually like grouped together in one sentence, or they'll usually be have something like this, or they'll say 3:2:5 or 3:5, or they're in the same sentence. I know that that's within one ratio, and then the second sentence will help me make my second ratio. But how I make sure that I put my numbers in the correct spot, I always want to write my words in front. So I'm talking about 3 inches wide and 5 inches tall. So the things I'm talking about is wide to tall. So 3 is talking about how wide it is. 5 is talking about how tall it is. Those are within the same sentence, so those go together. That makes one ratio or one fraction. My second ratio or second fraction to make up my proportion comes from the next sentence, and it says, how wide is the enlarged photo going to be? I don't know how wide, so that's my unknown. If it's 10 inches tall, so 10 is talking about how tall it is, and that's how I knew to put the 10 on the bottom. It's important to always make sure that you put your numbers in the correct spot, and that's why I always put the words in front, so then I know where to put this third number. So again, the numbers that go together in one sentence, that usually goes in one ratio. And then in my second sentence, those are what go in my second ratio. And usually there'll be an unknown and then a given piece of information. And you look at that given piece of information, what is it talking about? It's talking about tall. So that's how I need to put 10 down here at the bottom, because that's where the things that are talking about how tall it is goes. All right, now I just solve it like I did before. So I always want to go in the direction towards my unknown. So towards my unknown. 5 times what is 10? 2. So 3 times 2 is 6, which means it is 6 inches wide. And in case you forget, remember that the 6 is in the wide column, and double check. It's asking me how wide is it. Perfect. I answered the question. Let's look at the next one. The next one says, Sherwin-Williams claims that 5 gallons of paint will cover 1,500 square feet. If the Stanleys paint the interior of their home, which is approximately 4,500 square feet, how many gallons of paint will they need? Okay, so I'm talking about how many gallons of paint I need in order to cover a certain square footage, right? Well, that first sentence says 5 gallons will cover 1,500 square feet. Okay, so I used that because that went together. And then my next set of information, so after the period, it says, all right, so if they paint the interior of their home, which is approximately 4,500 square feet, so that's talking about the square footage, how many gallons? So how many gallons? The unknown is the number of gallons. Now that I have my proportions set up, remember, you always go in the direction of your unknown. So 1,500 into 4,500. So how many times does 4,500, if you were to divide that by 1,500? Here's a really nice zero trick. So remember, I'm doing this divided by this in order to find out how many times this goes into that. When you write that over itself, look, those zeros can cancel, those zeros can cancel, and now it's just a lot simpler. What's 45 divided by 15? Well, it's 3. So 1,500 times 3 is 4,500. So 5 times 3 is 15. And 15 was talking about the amount of gallons of paint needed. So 15 gallons of paint is what is going to be required in order to cover the 4,500 square foot house. All right. Let's explore a little bit more. If you keep going to problem 5, 6, 7, 8, okay, let's look at problem 5 and 6. It says, while training for a marathon, it took Joni 27 minutes to run 3 miles. At this rate, how long will it take Joni to run 10 miles? Okay, so we have certain many miles you go and however many minutes. Well, it says it took Joni 27 minutes to run 3 miles. So 3 went on top because it was talking about miles, and 27 went on the bottom because that's where I put the minutes. Now, as long as I stay consistent, I'll get it correct. At this rate, how long will it take Joni to run 10 miles? So 10 is talking about the miles, and miles was on top. So 10 is going to go there. And then how long will it take her to run that? We don't know how long. Now, unfortunately for this one, when I go to see, 3 times what is 10, and then to get to 27 to unknown, I don't know. 3 times what is 10? It doesn't go in evenly, right? So when it doesn't go in evenly, we can do what's called cross products, okay? So I'm going to take these two that are across from each other, 2,700, okay, or 10 times 27. See how the 10 times 27 is across from each other? So I'm going to multiply those and set those equal to these that are across from each other. The 3 times my unknown, or let's call it 3x. Okay, again, this is what we call using cross products to solve for my unknown. If it can't go in evenly, we'll just solve using cross products. And what those are what's across from each other, 3 in the unknown, and when something's unknown, we represent it with an x, and 10 is across from 27, so 10 times 27. 3x can't simplify, but 10 times 27 can. 10 times 27 is 270. Now to get x by itself, it's saying 3 times what is 270. So if I divide by 3 on both sides, that will help me figure out how many times 3 goes into 270. And the reason I do that is 3 divided by 3 is 1, right? 3 divided by 3 is 1. You agree with that? And 1 times x is just x. So now I have 1x on this side, and 270 divided by 3 is 90. So this unknown right here is 90. All right. The next one says Max read a total of 6 books in 3 months. If Max keeps reading at this rate, how many books will be read in 1 year or 12 months? Okay, so I'm talking about the number of books read in how many months? Well, it says he read 6 books in 3 months. Now, here's an important part to note. They kind of helped me a little, but if it just said at this rate, how many books, so we don't know how many books, will he read in 1 year? I can't just put 1 here because 1 is representing the amount of years, not months. So I would need to convert years to months. And I'd be like, how many months make up 1 year? Oh, 12 months. They told us that there, but had they not, I would have needed to know to put a 12 there because, again, this is in terms of months, not years. So if they wanted to know how many books in 1 year, how many months make up a year? All right. Now let's again go in the direction of my unknown. Well, 3 times what is 12? 4. So 6 times 4 is 24. So that means that they'll read 24 books. Now, luckily, this one worked out pretty nicely, huh? But I could have still solved this using cross products. I could have gone 6 times 12, because those are across from each other, equals 3 times what? Well, 6 times 12 is 72. And then to get x by itself, you would divide both sides by 3, because whatever you do to one side, you have to do to the other. And 3 divided by 3 is 1, so you have 1x. And 72 divided by 3 is 24. You still get 24. Okay, just in case this was another problem that it didn't work out nicely, I could have done cross products. Cross products will always work when solving. But if I can do this shortcut way of just 3 times what is 12? Oh, 4. So 6 times 4 is 24. Why not do the shortcut way, right? But just note that if for some reason you don't see that right off the bat, you can always fall back on cross products. Okay. This section right here, 5 and 6, actually was labeled using unit rates. A unit rate is when you have a denominator of 1, okay? And so if you get a denominator of 1, then you can figure out, okay, so if it's this amount for just one of them, then let's multiply it by the other amount and I can get my total missing. And the thing about using unit rates is it matters what's on top and what's on the bottom. And that's why I don't necessarily like using the unit rate to solve problems, because if I do the proportions, it doesn't matter which one I put where, as long as I remain consistent. Like I kept minutes on the bottom and I kept miles on top, and then I can always get my answer. But if I use unit rate, it really does matter what goes where. Okay, so let's draw ourselves a little note here. If you could also solve this by using unit rates. If I was asked to use the unit rate, it says, at this rate, how long will it take Joni to run 10 miles? Well, it'd be nice if I could just then like multiply my answer by 10. So I want miles to become 1, right? So then if I could figure out how long it takes you to do 1 mile, then I could multiply that by 10, and that would tell me how long it takes me to run 10 miles. So I'm going to put miles on the bottom and minutes on top. Okay, so they told me that it takes 27 minutes to do 3 miles. So let's find the unit rate. I want to know how long will it take me to run 1 mile. Well, how do I get this denominator to become 1? If you divide it by itself, right? 3 divided by 3 is 1. And whatever you do to the bottom, you have to do to the top. Well, 27 divided by 3 is 9. So now you have a unit rate. You have a denominator of 1. And it was important that we got miles to be the thing of 1 because they said, how long will it take to run 10 miles? So I want to be able to figure out how long it takes to run 1 mile, and then I could just multiply that amount by 10. Okay? So if it takes 9 minutes to do 1 mile, then multiply that by 10, and you figure out it takes 90 minutes. Again, this is why I don't necessarily like using the unit rates, because I really have to think harder about which one to get to become 1, but it is totally doable. Let's try it with example 6. See if you can figure out which amount should go on the top and which should go on the bottom if we were solving by doing the unit rate. Okay, and it says if Max keeps reading at this rate, how many books will he read in 1 year, or how many will he read in 12 months? So I want to be able to multiply 1 month times 12 months, so then I can figure out my answer. So you guessed it, months goes on the bottom, and books is going to go on top. Okay, so I use that ratio of 6 books in 3 months. I want to figure out the unit rate. How many books does he read per month in just 1 month? Okay, so divide whatever that denominator is by itself. 3 divided by 3 is 1. Whatever you do to the bottom, do to the top. 6 divided by 3 is 2, which means you can read 2 books per month. Okay, well, now that I know how many books I can read in 1 month, I'm going to take that amount, 2 books per month, and I'm going to multiply it by 12, because how many can you read in 12 months? 2 times 12 is 24, so you can read 24 books. I personally like setting up like a proportion and doing it that way better, but some people like finding how much it is for 1 and then just multiplying it by that other number. Whichever way you find easiest, you can use to solve. But just remember, if you're using the unit rate, it really matters which one you get to become 1. Okay? And typically, it's this thing right here. If it says 10 miles, well, then you're going to want to be able to multiply it by 10, so you want miles to become 1. This one says how many books will be able to be read in 1 year, which is essentially 12 months. Well, since I'm going to want to multiply it by 12 months, I want months to be able to become 1. So that's the thing that has to go on the bottom. And that's the trick for when you're using the unit rate. But again, you can do it either way. It's just a matter of preference. Some people think that this makes way more sense to them, so they use this way. Others like just doing the proportion way. Okay, since proportion is my favorite, I'm going to use it to solve these two, which is called scale drawings. And scale drawings are essentially what they use a lot of times if they're doing a map, because just think how hard a map is to fold. What if it was the real size of the actual state? Like, how in the world could that even be possible? That map wouldn't be able to fit in your car, right? Or if they make a mock-up of a building, they want to see first, before they waste all that money building the material, they want to plan it out on a smaller scale and make a little tiny toy figure almost of it, and then talk about, oh, let's change this and that, before they waste all the money building it in real life size. And so this is when we use what's called a scale. Okay, so what I like to do to help me make sense of this is I always put scale to actual or scale to real life whenever I notice it's going to be a scale problem. And then if they use units, I include the units for the scale and the units for the actual. So for instance, this one says, on a map of my hometown, the distance between the middle school and the library is 2.5 inches. The scale shows that 1 inch is equal to 5 miles. So what do you think is on the map? Inches or miles? Obviously, inches represent how many miles in real life, right? And the scale says 1 inch is equal to 5 miles in real life. So then if it's 2.5 inches on the map, so on the map, 2.5 inches, how long is that in real life? Okay, well, go towards your unknown. So go in this direction. 1 times what is 2.5? 2.5. So do 5 times 2.5. Go ahead and get your calculator out. And you'll see that that equals 12.5. So that means in real life, if it's 2.5 inches on the map, it's 12.5 miles away in real life. Okay, you could have used cross products to solve it if you didn't see it right away, but this one was simple enough to just do the little hack. Okay, and finally, our last problem says on a map, the scale shows this. So let's write, okay, we have scale to actual. And the units they used, again, were inches for the scale and miles for real life. And it says 1 inch on the map is equal to 12 miles in real life. If the distance between Tampa and Orlando measures 7 inches on the map, so we're talking about inches on the map, there's 7. What is the actual distance in real life between them? Okay, so that's my unknown. Well, let's go in the direction towards my unknowns. 1 times what is 7? 7. So 12 times 7 is 84. And this unit was talking about miles. So it'll be 84 miles in real life if it's 7 inches on a map. Okay, and you don't have to follow my example of using scale to actual. If it makes more sense to you to do map to actual, that's fine. Okay, whatever makes the most sense to you. Just make sure that you label it so we know it's clear what you're talking about and that you stay consistent. The map always stays on the top, the actual stays on the bottom. Okay, now once you're done with this, let me zoom out. See this solid line in the center? I'm going to fold this up to that solid line, and I'm going to fold the top part down to that solid line. Okay. And here we go. Then you go ahead and you flip it over, put some glue on the back, and then glue it in to your spiral notebook so it looks like this. Congratulations on mastering some pretty hard concepts here. Okay, how to write and solve proportions and using